We're going to cover a few last little topics that are going to be useful for this module's homework. The first is to look a little bit further at iteration. When we iterate through items in a list, we of course want to know which items in the list there are, and that's what we're getting when we iterate over the list. But we also often want to know which item number we're looking at. Let's just look at a simple example of this. Suppose we define a list called foods and just has some nice fruit, maybe some peaches, apples, and grapes. And if we want to iterate over the list, we can do this by writing a for loop for each food in foods, and we can do something like simply print out the food. And if we run this, it will print out the foods one at a time: peaches, apples, and grapes. Now suppose we want to know which food number it is. That we want to know that peaches is food at index number 0, apples is index number 1, and grapes is index number 2. Well, since the for loop just gives us the item itself, the only way we currently know how to do that is to define a new variable. Maybe we'll call it index, and we start it off at its starting index. We can then print that along with the thing that we're printing, convert it to a string, add a little separator, concatenate the food item, and then of course don't forget to increment the index. And now when we run it, we see that we have a bug because while we incremented the index, we didn't actually use the index. Maybe you noticed that when I was typing. So now when we run it, we get what I had expected, which is the index of each item. This is fine, it works well, but there's two ways we can improve this code. The first is, you may have even seen me do this already, it is very common to take a variable and modify it by doing something like adding 1 to it, or multiplying it by 2, or doing some simple mathematical operation to the variable. This is so common that most languages, including Python, have an operator that combines assignment and arithmetic. And you can see here what that looks like. When we say plus equals to a variable, it will essentially, well, this will do exactly the same thing as assigning to index the result of adding 1 to index. Alright, that's a nice simple improvement. I run it and no change. But what I really want to do is get rid of index altogether, because there's a whole extra thing I have to manage when surely Python knows about which item is in the list. Well, it turns out that there is a way to do this, and we can do this by deleting our index variable, and instead of just iterating over the list foods, I'm going to iterate over the result of calling the enumerate function on foods. And without going into the implementation details yet about enumerate, what it does is it returns essentially a combination of the index number as well as a way to iterate over the list. And when we do that, we can actually change the way we use the for loop. Instead of just giving it a single variable, we can give it two variables: for variable, comma, variable in the enumeration of foods, where the first variable is the index into the list and the second variable is the item in that list. When I run this, it's going to do again exactly the same thing, but we didn't have to maintain the index variable ourselves. So a nice simple improvement in the code. Just like the for loop can take two variables while you're iterating, it turns out Python has a similar kind of syntax in other places, and the place I want to use that other kind of syntax is when we return a variable from a function. So far we've always returned a single variable from a function so the caller can get the value that a function returns. That works very well a lot of the time, but sometimes you might want to return multiple values. If you have different values that you want to return, how do you do that? Well, we already know one way to do that. You could just make a list containing two values and return the list, which is a single object, and then the caller could extract the items from the list. Let's start with that because that's something that we know how to do. Let's suppose we were to define a very simple method called powers, and what it will do is return the number and the number's square. Well, we can't, if we want to return two things, as I said, the way to do that is to put it in a list. So now let's call powers, pass in the value 5 and print out the result. And it will print out the list 5 and 25. So if we want to do something with that and maybe make it a little bit prettier, then it's a bit annoying, right? What we have to do is store the result, say result equals the result of calling powers, and then we can say something like print result of 0 plus a string, and say it's square equals result of 1. And to do this, you really have to know exactly the format that result returns the string, returns a list. As is usual, I forget to put my numeric values inside an str call to convert it to a string when I'm concatenating it with other strings. Anyway, this works. I get the result that I want. A simpler way to do this, as I've been implying, is instead of returning a list containing multiple values, that is, instead of returning a single item that contains multiple values, we can actually return multiple items. So if we just return one item and another item, now when we call powers, instead of it returning a single item, it returns 2, so we have to assign it to 2 variables. So we'll say it returns a result and its square, right? We assign the result of calling this function that returns 2 values into 2 variables. So now when we print it, instead of presenting a result of 0, we just present this result and its square. And when we print this, we get exactly the same result, but it's nice, simpler, cleaner code. The last thing I want to talk about is how to store a grid or two-dimensional grid of data in Python. Well, we already know how to use lists to store a one-dimensional sequence of items. And we know that in Python, a list can contain any object, including other lists. And we're going to use that trick to store our two-dimensional grid. We're going to generate a list of lists, where the first list represents essentially the list of rows, and each row will be another list which contains all of the cells in the grid. I've written a bit of code here that generates a simple grid of cells that are initialized with a single character, a dash, and then prints it out. I have a variable called size that will let us control the size of the grid. I've just set it to 5. But let's take a quick look at how this works. First of all, there's a function called genRow. This is straightforward. It initializes a row variable, and then it iterates size times, and for each iteration it adds to the list the dash character. And so when we call genRow, it generates a list of size dashes. Alright, so that's one of our rows. And now here's this more general init function, and again it iterates size times, and what it does is for each iteration it generates a row, which is a list, and it adds that row to cells, which I had previously initialized. And so cells becomes the list containing lists. Sounds tricky, but it's actually pretty straightforward. It's just a list of lists. Each item in the list contains other lists. So now I have a little utility function called displayGrid, and what this is going to do is going to print out the grid, and this is how it works. It iterates size times for each row, and then for each row it's going to generate a string representing that row, and we do that with the following code here, these 3 lines. I initialize row here to be an empty string. I iterate size times, and now for each of these cells we access the contents of the cell, and this is the cool part. Cells of row num of col num. So we already know that cells is a one-dimensional list, and so you can access the item in the list like this with this index, row num. We've seen that before. But since cells of row num is a list, we can access that list by adding this second index accessor with col num to access that cell. And the result is it acts like a single, it acts as if it were a single data structure that that represented a two-dimensional grid. where you can give it two indexes. The first is the row num, and the second is the column num. So anyway, it generates this string representing the row, and then for each row it prints it out. Let's run this code, and we see what we've got is a grid of 5 by 5 dashes. Actually, when I printed it out, I added a space after each cell, which is why there's a space between the dashes. And just to show this works, maybe I'll change the size to 3 and rerun it, and now we get a 3 by 3 grid, or maybe we'll make it larger, set it to 8, and now we get a larger grid. I recognize it still may be a little bit confusing, so let's take a look at a picture that shows what's going on in a little bit more detail. When we create that first row, what we're really doing is creating a list with 5 elements in the list. Each one contains a string, which is that dash. Then what we do is we take that list and we assign it to be the first item in another list. I'm just going to draw this one vertically, but it's really just another list. And its first cell, its content, is essentially a reference to this second list. And then we iterate and we do that 5 times. So we create another list with 5 cells. And we assign that to be the value of the second item in the cells list. And then so on. We do this a 3rd time, 4th time, and a 5th time. Those are all lists. And when we're done creating our grid, this is really the data structure that we have. And so then we access it by accessing cells. So if we were to access cells of, say, 2, what that would do is that would access this item here, right? 0, 1, 2, 3, 4, and that would give us this row. Suppose we want to access a particular cell like this one here. Well, how do we access that? Well, it is the 4th item in cells, which is index number 3, and then we can access this row by accessing its item. So we access cells of 3, which gets us here, and then we access item number 3 within that row, which is here. So cells of 3 is going to get us here. So here's a question for you. Suppose you want to access this cell here. How would you access it? So now let's take one last look at our 2D grid and see if we can take our empty grid and put in some random data. Let's say we can take some number of cells and replace them with asterisks. Let me make this smaller again. Say it's 5. So we're going to need some random numbers, so I'm going to import random. And I'm going to add a new method called populate. And what this is going to do is generate, say, 10 random numbers. 10 random cells. It'll fill in. What this is going to do is to fill in 10 random cells with asterisks. So what we need to do is generate the location of random cells. And each cell has 2 numbers, right? A row and a column. So for each cell, we have to generate a random row number and a random column number. And that should be in a valid range of the indexes. Now, since the grid is a dimension of 5, at least, or size rather, right now it's set to 5, then it should have values between 0 and 4, or between 0 and size minus 1. So let's go ahead and generate those numbers. We can use the same randint function we've been using for a while, and we should generate random integers between 0 and size minus 1. And we'll do that for both random row and column number. And now that we have this, we can access the 2D grid directly with cells. Cells of row num, col num, remember that's a new random location, is going to be an asterisk. So we've just taken the dash on 10 different cells and replaced them with asterisks. So now, instead of displaying the grid after initializing it, let's first populate it and then display it and see what we get. And sure enough, we have a grid with hopefully 10 random asterisks. 1, 2, 3, 4, 5, 6, 7. Why don't we have 10? Well, remember all the work we've done on generating a unique sequence of random numbers? We didn't do that, did we? So it looks like just by bad luck, we happen to have generated the same cell location multiple times. But every time we run this, we will get different cells, different set of random numbers, or random locations. And if we make this bigger, say back to 8, we'll still have 10 random cells that are set to asterisks, but they're going to be in a larger grid.